and this is also a triangle, right? They are similar. You can see, right? For example, we all human beings are similar, right? We have two
Yes.
hands, two nose, one nose, two eyes, everything. So we are similar somewhere. All human beings are homogeneous. See, same. But congruent is, for example, the twins. They are congruent, right? Because their everything is same in them, right? The
Yes.
color, texture, height, everything is same. So all squares are basically similar. Why? Because all the square are of same shape, but size may not be same. Hence these are similar but not the congruent. Okay, this is also a square, this is also a square, but you can say size is different. But for example, if I'll draw a square which is of same size, then you can say, ma'am, these are congruent,
Congruent.
right?
Yes.
So the answer is similar. Then the next one is all dash triangles are similar. So basically, this is basically you have to learn. So isosceles triangle. So what is the difference between isosceles and equilateral? See, over here, isosceles triangle, they have two equal sides, right?
Yes.
Now, if the isosceles triangle ABC, right, and triangle DEF. So over here, AB equals to AC, right, and DE equals to DF. Okay. So when you will divide it into same ratio, you will get this. So sides are not in same ratio. Hence, isosceles triangles are not similar.
Similar.
Okay. But equilateral triangle, you can say, ma'am, they are equal, right? Everything is equal over there. 12 to 12, 13 to 13 like this, right? Equilateral triangle, right? So you can say that, ma'am, equilateral triangle are similar because in isosceles triangle, they have two sides equal, right? Two
Yes.
sides will be equal, but not the all sides, right? So that's why they are not
Yes.
similar. Only
Similar.
equilateral triangles are similar, right?
Yes.
Okay. Now the next one is this. Okay, wait. Third. I think I missed. Is it? Okay, just a minute. Huh? I think. Okay, I missed the third one, I think. Okay. This was third, na? This was third. Okay. I missed
Yes.
the second one. No.
Yeah. All squares are dash
We
similar
did this.
or
I
congruent.
think I didn't mention the first one.
No, no, you didn't mention the second one. Oh wait, you didn't mention the first one. Yeah.
Yes, circles part, right?
Yeah.
All
Circle.
circles, yeah. All circles, you can, I think you can answer it, right?
Yes. All
So all
circles are
circles are
similar.
similar to this question. Tell me.
Yes. All circles are similar.
Yes, but not congruent because maybe, for
Yes.
example, if you are taking radius 2, you will draw it like this. If you are taking radius 4, then it will be like this. So they are not congruent, right?
Yes.
Okay. Now, fourth one, two polygons of the same number of sides are similar if their corresponding angles are dash and their corresponding sides are equal and proportion. So over here, you have to mention it. So see, very, very important. They can ask you this. Two polygons. It can be any shape, right?
Yes.
So if they have same number of sides. So for example, if you are taking triangle, then other one will be a triangle. You cannot compare a triangle and a rectangle, right? Because triangle you have three sides and rectangle you have four sides,
Four
right?
sides. Yes.
So their corresponding angles are always equal, right?
Yes.
Because they are similar. Okay. And then their corresponding angles are equal, but their corresponding side will be proportional.
Proportional.
Yeah. This
Yes.
is what we did, right?
Yes.
Yes. So this will be the thing. Now coming to question number second. So give two different example of a pair, similar figure. So any two rectangle, right? Any two square or any two triangle, anything can, right? So no need for this. Then the next one, second non-similar, you can compare a circle and a triangle or a rectangle or a square, anything, right?
Yes.
Coming to question number third, state whether the following equilaterals are similar or not. Okay, so these are the things. Okay, so the polygons of the same sides, the polygon of same number of sides are similar if their corresponding angles are equal and their corresponding sides are in ratio. Okay, so they can be similar in these two conditions. So now we will look whether these conditions are matching. So in case of these two quadrilaterals, angle DAB is 90 degree, you can see, right?
Yes.
But is this
No.
no? So, of course, the first condition is not satisfied. Therefore, they are not similar. Because to have like any polygons, we did it, right? Any polygons will be this one, right? Any
Yes.
polygons can be similar, right?
If the
If these
corresponding
two
sides
conditions
are
are satisfied. Yeah. So you can write down the in book itself. You can draw it like this if you want. Others, I hope this is very simple. Non-similar. Any two you can compare
yes.
similar. But this one you can write it down. Okay.
Okay, teacher.
Then we'll start with the examples.
Yes, teacher, done.
Okay. So now we'll just do the examples. Okay.
Okay, teacher.
Okay. Before starting with the example, basically we don't have to do all the examples. We have to do only till 8. Okay.
Okay, teacher.
And rest of the examples they are deleted. Okay.
Okay.
Now this is what you have to remember. Like we are going to do the 8 examples, right? But out of these, second one, fifth one, seventh one, and eighth one is most important, right? So if you have your book, you can mark it there only, or you can write in a notebook. You can write example number 2, example number 5, example number 7, and 8 most important. Okay, so that when you are revising all the examples, you can revise these thoroughly. Like in theorem 10 6.4 was very important, right? As I
Yes.
mentioned. And similarly in examples, these 4 examples, like all are equal. I'm not saying that these are important, so only they will come. But probability of these type of questions, like these type of example, is higher as compared to other. But nobody knows. Like maybe they can ask you third one or fourth one. But yeah, some prediction is there that these are important. Okay. So you
Okay,
can quickly
teacher.
write it down. Then we'll start with example one.
Okay. Yes, teacher, done.
Okay. Just give me 1 minute. We'll start. Okay.
Okay, teacher.
Okay, so let's just start with example number 1. Okay, it is if line intersects side AB and AC of a triangle this respectively is parallel to this. Okay, you have to prove this one. We did this, right?
Yes.
Right. So over here, like given is this, that ma'am, triangle ABC, these lines are this, like given. Then you have to prove that ma'am, AD divided the first one. I hope you remember, right?
Yes.
So
Yes.
proof is we know that the line drawn parallel to one side of the triangle intersect the other two sides in distinct point. Then it divides the other two sides in the same ratio. Therefore, this is equals to this. Okay. So now you have this. You will add 1. We did this, right?
Yes.
Yes. So you will add 1 and somewhere you will get this. Hence proved. Okay.
Okay, teacher.
So over here they have written the entire theorem, right?
Yes.
Yes. So that's why the theorem were important, because if you are not aware of this, then how will you prove it? Okay.
Yes, teacher done. Yes, teacher. Done.
Okay, so now we'll do the next example, which is ABCD is a trapezium with AB is parallel to DC and E and F are the point on non-parallel sides. Okay, basically AB and DC they are parallel, but AD and BC are not parallel, right? So E and F are basically the point on non-parallel sides. Okay, and AD and BC respectively, such that EF is parallel. So they are these point A, E, and F. They are making the points in, and they are drawing this line in such a way that EF is also parallel to AB. Okay, you have to show that AE and divided by ED is equals to BE. Sorry, BF divided by FC. Okay, so again, what is given? ABCD is a trapezium. These are parallel. These are points on this side, and EF is parallel to AB. This is given. Okay. What you have to prove? You have to prove this. Okay. Let's just start. Proof. So it is given that AB is parallel to DC. Yes, ma'am. And EF is parallel to AD. Okay. Clear?
Yes, teacher.
Okay. It's AB, not AD. Wait. Okay. So over here, so also EF is parallel to DC, right? If it is parallel over here, you are getting the point. See,
Yes.
AB is parallel to DC, right? And plus
Yes.
EF is parallel to AB. So of course, you can say that EF is also parallel to DC,
DC.
right? Because lines which are parallel to the same line are parallel to each other, right?
Yes.
So now what you will do, this is your construction. You will join AC, this one, right? Let AC intersecting EF at point G. So this of course line will intersect. So this point will be your G point. Okay. So this theorem is very, very important. Okay. So now in triangle ADC, this triangle. Okay. You are getting it. Again, you constructed the triangle, right? Now you
Yes.
have this line, right? So
Yes.
similarly, you know other things, right? So
Yes.
So now in triangle ADC, EG is parallel to DC because it was like EF was parallel to DC. So of course it will be parallel to this as well, this EG, right?
Yes.
And then AE divided by ED equals to AG divided by GC. Yeah, ma'am, same one. We already know this. Line parallel to one side of the triangle intersect the other one, right?
Yes.
And then similarly for triangle this, right? Over here, this is the line, right? So similarly also AG divided by GC and BF divided by FC. They will be also equal by
Yes.
same theorem. Okay. So you can write according to theorem as well. Theorem, if this is 6.1, 6.1, it is 6.2, 6.3, whatever it is. Instead of writing the entire thing, you can mention theorem 6.1 or whatever it is. Okay.
Okay, teacher.
Now from first and second. Now you have these. This was your first. Okay. I have written it here. And the second. What you will get? That these three are equal. Right?
Yes.
Yes. So that's why this is also equal. Hence proved. Yeah.
Yes.
Very simple, but the only trick was most of the students like, ma'am, this is a triangle chapter from where we get this trapezium,
Trapezium.
right? You have
Yes.
to make it triangle and then you have to solve accordingly. Okay?
Yes, teacher.
So,
Yes, teacher, done. Teacher, I have a doubt.
Yes.
Instead of writing joining A and C, let AC intersect EF at point G in roof, can we write it for construction? Like, can we
Yes,
give
yes,
it?
yes, yes, you can. It will be better.
Okay,
Okay.
teacher.
Yeah.
Teacher, can you scroll a little down? Yes, teacher, done. Yes, teacher, done.
Okay. So let's just start with the example number 3. Okay. So over here in figure, this is the figure. PS divided by SQ, okay, is equals to PT divided by TR. Okay. And this angle is equals to this angle. Okay. You have to prove that PQR is an isosceles triangle. So isosceles triangle, you know the property that its two sides are equal, right?
Yes.
So if you will prove that this PQ is equals to PR, right? That will be also fine. or you can prove these two sides. If you will prove that these two sides are equal, then yeah, you can prove that it's the isosceles triangle. So whenever they are asking you to prove any triangle, you should know the property that isosceles triangle means what. Okay.
Two sides are
So
equal.
yes. So given is, this is given, P is divided by this, and also the angle. Okay. Now you have to prove that it is an isosceles triangle. So let's just start. So it is given that P is divided by SO is equal. That means, because this is given, so that means this ST is parallel to QR. You know the property. If the line divided by any two sides, this one, right? Yes.
Yes, teacher.
Right. So earlier what we were doing, parallel was given, we were writing the ratio. If ratio is given, then we will write parallel. Okay. Then now since ST is parallel to QR, so that means PST is equals to PQR. This one, corresponding angles, right?
Yes, yes.
Because this is, these lines are parallel and this is the
Transfer.
transverse, right? So these two are
Yes,
equal. Okay.
corresponding.
Yes. And also PST, this one, and PRQ. Again, this is equal because you know corresponding angle. So this is
Mhm.
first, this is second. Okay. So from first and second, over here you can see PST is equals to PQR and PST is again equals to PRQ. Okay. So
Okay.
you are getting this one.
Yes,
Okay. Instead of taking this one, they took the alternative one, this one and this one, right?
yes,
Because they are equal now. You know
yes.
this. So
Yeah,
instead of writing this, you can write this. Okay.
yes.
So here you got PQR equals to PRQ. Okay. You got this. So next PRQ, you got it. So sides opposite to equal angles are equal. So you have the property like when we were, I think in 8th class, we did it. If angles are, for example, these angles are equal. Okay. So these means these two sides will also be equal. Right.
Yes,
This is a property of triangle that if angles are equal, like opposite angles are equal, then their opposite sides will be equal, right? And if opposite sides are equal, then their angles will be equal. Okay. So over here, what we proved that PQR, okay, is equals to PRQ. This one, we proved it.
yes.
So opposite angles are equal. So that means their opposite sides will be equal. So
Equal.
PQ will be equal to PR.
PR.
Clear?
Yes.
So hence proved. Clear?
Yes.
Any doubt?
No.
Okay. So wait, I'll just erase it. Over here it's incomplete, just complete it. Okay. And this is equal. Okay, you can write it.
Yes, teacher. Done. Yes, teacher.
Okay. So we'll do the next one, which is example 4. So in a figure, you can see PQ is parallel to RS. Okay, right? And you have to prove that this triangle is similar to this triangle. Okay, so this is given. You have to prove this. Let's just prove it. Very easy. What you have to do in triangle, this and this, right? This is given that PQ is parallel to this, right? So if these lines are parallel, so this means this is a transversal, right?
Yes.
Yes. And this is
Yes.
also a transversal, right? So over here, first thing is that in these two triangles, in triangle PQR and in triangle this, right? First of all, this angle and this angle, they are equal vertically opposite angles, right?
Yes.
And this angle is equals to this angle, alternative interior angle, right? And this
Mm.
angle is equals to this angle, alternate interior angle. Why? Because this PQ and PRS was parallel. So if this is parallel, right, this will be the transversal,
Transfer.
right? And
Yes.
also this will be the transversal. So yeah, the if using AA similarity criteria, this triangle is similar to this triangle, hence proof. Yeah.
Yes, teacher. Yes, teacher. Done.
Okay. Now the next one, example number 5. Okay. You have to observe the figure. Then you have to find angle P. This one. Okay. So over here, what is given? AB is given, PQ is given, BC is given, QR is given, AC is given, and PR is given. Okay. You have to find angle P, that is this one. Okay. So you know, in triangle ABC and PQR, let us find the ratio of sides. Okay. Ratio in the sense, you know, AB divided by RQ, right?
Yes.
Yes. And then AC divided by RP, right?
Yes.
And similarly BC and
Q.
QP.
QP.
Okay, so you will put the ratio, you will get 1 divided by 1 divided by 2. So this means that their ratios are equal, right? So if
Yes.
their sides are equal, the ratios are equal, that means these two triangles are similar,
Yes.
right? If this then if this triangle is, hmm? Tell
Oh,
me.
what happened?
Okay, wait. Okay, so now over here you are saying that AB and RQ. So this
Yes.
means angle B is equals to angle Q,
Yes.
right? And angle C is equals to angle P. So
P.
with this, can you find this C?
Yes.
Once you got C, you can write that, ma'am, these are equal. So you will find C. I hope you will find it on your own. Okay?
Yes.
You know the angles and property, right?
Yes.
So first of all, what you will do, you will write it and then you will find C on your own, and whatever the C will be, it will be equal to P.
P.
Okay?
Yes. Okay. Yes, teacher, done. Yes, teacher, done.
Okay, so what was your C?
Uh, P is equal angle P is equal to 40 degree.
Yes. So I hope you wrote it like this only. Okay,
Yes,
in bracket you have to mention that angle sum property or sum of angle is this. Okay.
teacher.
Okay. So let's just start with the next one. Angle example 6. In figure, this figure in figure OA, this OA, this dot means multiply is equals to OB equals to OC multiplied by OD. Okay, so that means OA, this one multiplied by OB, right, is equals to OB, right? Sorry, OC the multiplied by OD, this one, right? So this dot means multiply. Okay,
Okay, teacher.
you have to show that angle A, this angle A is equals to angle C. Okay, and angle B is equals to angle D. Okay, you have to show it like this. Okay, so again very like somewhere easy but little bit of complication. Okay, so you know this is what you have to prove. Okay, see, in case if they ask you to prove this, it's very easy, no? Angle A is equals to angle B,
B.
because you just have to prove that these lines are
I,
parallel and you can easily do it, that
yes,
okay, parallel. So yeah, but over here you have to prove this, you have to prove the other thing, that OA multiplied by this is equals to this. This is what you have to prove. Okay, so let's in this triangle this and triangle COB. Okay, this OA divided by OC. Okay, OA and the part of OC and OD of this and OB of this. Okay, getting the point?
yes, teacher.
If see, it will be like this now. For example, this line, it is forming the triangle. So this one is equals to this one, and this one is equals to like divided by this one, right?
Yes, teacher.
Okay, so this is what. So if you know that this is what, then you can say that this angle is equals to this angle, right? Because you know this, so that means this is parallel to this pair, right?
Yes, teacher.
Yes, because they are in ratio, so that means they are parallel.
Yes.
Okay, so if they are parallel, that means they are forming these are the transversal, and this will be equal to this vertically opposite angle, right?
Yes.
So if you can say, ma'am, again, but you know this is equals to this, plus you know these angles are equal, plus you know this side is equal to this, everything you know. So that means these two triangles are similar. Yes,
Yes, teacher.
right? So we know that if two triangles are similar, so their corresponding angles are,
Equal.
well, so these two triangles are similar. So that means this triangle, this will be equal. Getting the
Mm.
point? Because
Yes.
this somewhere you are going to keep it like this, right? This will be, this side is equals to this side, and this side will be equals to this side. So this angle will be equals to this angle, and this angle will be equal to this angle. So this angle will be equal to this, and this angle will be equals to this, right?
Yes, teacher.
So hence proved. Clear?
Yes, teacher. Yes, teacher. Done. Yes, teacher. Done.
Okay. So now next one, example number 7. Okay, it's like a little bit lengthy. So what we will do, we will do this in next class because yeah. Okay. We will first do example number 8. Okay,
Okay, teacher.
because that's a lengthy one. Not lengthy one. It's though. Okay, let's just do it. If in case we are running out of time, we will take the screen. Okay. Okay.
Okay, teacher.
So a girl of height 90 centimeter is walking away from the base of the lamp. Okay, this base means below it. At the speed of 1.2 meter per second, if the lamp is 3.6 meter, this is the lamp, okay, above the ground. Find the length of the shadow after 4 seconds. Okay, so basically she is here. So of course the shadow will be here, right? Yes.
Yes, teacher.
Okay, and you have to find the length of her shadow. Clear?
Yes, teacher.
So let's just do it. Girl of height 90. Okay, so see what is happening. They have given you this as well as they have given you the height of girl. Okay, so over here you can see this is in centimeter and this is in meter. So of course it's a problematic thing. First of all, you
Yes.
will convert this 90 centimeter into meter. So lamp is given AB 3.6, right? But height is given in centimeters. So you will first convert it into meter and speed is given. These are the three things given. Now you have to find length of a shadow, that is DE. Okay.
Okay, teacher.
And the girl walks DB distance in 4 seconds. So this DB distance or BD distance, she is walking in 4 seconds. So first of all, you know the speed, right? You know the time. So you will find it how what the distance she covered in between, right?
Yes.
So speed is equals to distance divided by time. So speed, you know, 1.2 dB distance is this, right? So once you will solve this, you have time. So once you will solve it, you will get 4.8. So basically this BD is your 4.8. Clear?
Yes.
Okay. Now in triangle ABE, this triangle and triangle CGE. Okay, these are the two triangles. Basically, you have to find this one. Okay, right? So these are
Yes.
the two triangles. Over here, what is happening? Angle E is equals to angle E because in both it is common,
Common.
right? So it's
Yes.
common. Angle B is equals to angle D. Why? Because both are
90 degrees.
yes. And then therefore, with AA similarity criteria, you can see this triangle is congruent to this triangle, right?
Yes.
Yes. So we know that if two triangles are similar, then their sides are in proportion. So that means
Yes.
BE, this one, BE divided by DE, right? And
Yes.
AB divided by CD, right?
Yes.
This is what. Then what you are going to do? You are going to do this, like you will add it, right? This one, BE. How
Yes.
you are making BE?
BD.
BD
BD.
plus DE,
BD plus
right?
D.
So you will split
Yes.
it. Okay. Now you will put the value 4.8 plus because you don't know the value of BE,
D.
right? So that's why you need to split it because you know this, but you don't know this, right?
Yes.
So again, this equals to this. Other value, you know everything,
Yes.
right? You know AB, you know CD, everything you will put. You will put the value and you will get the answer. Clear?
Yes.
So I hope you know the division part over here. It's 3.6 and 0.9. So that's why you multiplied it,
By
right?
10.
Yes.
Yes.
And similarly over here it is DED. So somewhere you have, and then till here it's fine. Okay. Now this DE will come here,
Yes.
right? So it is 4DE. Then this DE will come here. So 4D
Minus
minus DE will be 3DE.
D.
Like this you will solve.
Yes.
Okay. We have time. We have, I think, 4 minutes. So just do this and rest. I think just note it down till here. I think till here, this one you can do, right?
Okay. Yes, teacher. Done. Yes, is it done?